Hi, welcome once again. VHDL tutorial part 2 presented by Transwiz Technologies. Transwiz Technologies. In the last tutorials we have seen about the design units. Entity declaration, architecture body, configuration declaration, package body. Now we will see about that entity declaration. The entity deals with it. I have already said that the entity which deals with the external view of the model. We just consider the half adder. Here A and B is given as the input and we are getting sum and carry as the output. So the entity part which deals with the A, B and sum and carry which we are calling as the inputs and outputs. Here that entity description. In C languages, in whatever the languages we are saying syntax now, similar things in entity also, in VHD also syntax is the entity and then we want to write the entity name and is port and open braces port declaration inputs and outputs and then close braces semicolon and end what the entity name, the same entity name want to be ended and semicolon. There will be describe the entity part. Here port which deals with the input and output port. Entity, port, is, end or we are calling as a keywords. For example, you just consider the half adder diagram. We have seen that block diagram now. For that AB is a input and SC as a output. Means sum and carry. I am here representing as a SNC. Sum and carry as SNC. Entity, here the entity name is half adder. Is a keyword and port open braces and port declarations that in that port declarations I want to declare what the inputs and what the outputs. A and B are acting as the input, therefore A comma B colon in standard logic, in which deals with the input, out which deals with the output. Standard logic we can also write bit, in bit output also, and close braces semicolon and end the same entity name as a half adder. This will say about the entity declarations. In port declarations, what are the types of the in out buffer. In which deals with the value of the input port, only read within the entity module, okay, and output, out, the value of the output port. It can be updated within the entity module, it cannot be read. Out is not readable. In out, it's a bidirectional port, we can read and update within the entity model. And another one is a buffer. The value of the buffer port can be read and updated within the entity module, but it differs from the in out. How? Same process going on, it's reading and updating within the entity model, but how it's going to be differ. It cannot have more than one source. It connected to be either buffer port or signal within most one source. Okay, that's the difference between the input and buffer. Architecture body, we have seen about the entity now. Now we'll see about the architecture body. We have already studied about the structural data flow behavior. Data flow is not nothing but RTL, register transfer level. Structural modeling, a set of interconnect components. Now to interconnect the components, we are going for the structural modeling. Data is a concurrent statement and behavior modeling is a sequential statement, and mixed modeling, any combinations of the above modeling is calling as a mixed modeling. And now we'll see about the data flow modeling. We have already a set of concurrent signal statement, right? Here also we are having some syntax. What is it? Architecture name of entity name is, and then signal declaration. If any signals is there, we want to declare over there. And begin concurrent statements end same architecture name. You just consider this diagram a full ladder, right? The internal view of that block diagram. XY is going to be acting as the input, is it XYZ, and sum and carry SC, sum and carry is going to act as the output. So now we'll go for the program. Here architecture, BH will be act as the BEH will be act as the architecture name of. Here architecture of is signal, begin, end. These are going to be acting as a keyword. Standard logic, these are going to be acting as a keyword. So architecture, the architecture name is BEH. It whatever it may be, full adder 1 or full or whatever it may be. Here I am writing BEH OF keyword, that name of full adder. The entity name is full adder, na? So here writing the entity name full adder is. And in the diagram we are getting X exclusive OR. Here in the entity part we are declaring only the X, Y, Z only and sum and carry. Inside that gates we are getting some outputs now. X and Y XOR to give X XOR with Y. It's going to be acting as a signal, a wire, or variable. Here I am considering as a signal. In Verilog we are saying as a wire. Here I am saying as a signal. So I want to give X exclusive OR of Y one signal and XY one signal, S exclusive OR of Y exclusive OR of Z one signal, and X exclusive OR of Y and with Z one signal. Okay, so totally I want to have 4 signals. That's why I am returning as a. So how many signals? 1. Oh, it's going to be acting as, sorry, S exclusive of Y exclusive of Z is going to be acting as a sum. Now there is no need to consider signal. This is output. So I am going to consider 3 signals. Okay, X exclusive of Y, XY, X exclusive of Y and Z. So I am giving signal standard logic. So how we are going to get, and begin which deals with the starting of the process, of the program. X naught is equal to less than or equal to we are going to calling as the assignment operator. It's assigned to X naught is assigned to, or X XOR of Y assigned to X naught, like that. So the RH is assigned to the LHS. Here how we are getting that X naught X exclusive of Y is equal to X naught, and X1 will be X and with Y, X2 will be X naught and with Z, and sum will be X naught XOR of Z, and C will be, carry will be X1 XOR of R, and end we want to give the end architecture name. Now the architecture name here is BEH, so I am giving BEH and BEH. This thing is the architecture body of a program. What I have said in the programs, behave is architecture name and full is entity name. Signal is a variable used to this program rather than in the input and output. Other than the input and output, whatever we are having in the programs, we are going to call as a signal. Begin is the starting part of the program and end is the ending part of the program. In between begin and end we are having some statements now, what we are calling as the concurrent statements. Okay, these are concurrent statements, and these are about the data flow modeling. That it is a modeling, na, data flow, structural and behavioral. Now we are seeing about the data flow modeling, and in the next tutorials we will see about that behavioral modeling and structural modeling. Thank you for watching a VHDL tutorial.